A company is launching a new smartphone and you're in charge of the online configurator. Customers can choose from 3 different screen sizes, 4 storage capacities, 6 colors, and 2 camera modules. How many completely unique versions of the phone can a customer design? To solve this, we'll use the fundamental counting principle. This principle states that if you have a series of independent choices, the total number of combinations is the product of the number of options for each choice. So we have 3 choices for the screen, times 4 for storage, 6 for color, and times 2 for the camera. Let's multiply them out. 3 times 4 is 12, 12 times 6 is 72, and 72 times 2 gives us a final answer of 144. There are 144 unique smartphone configurations possible. Here is an IB tip. This multiplication rule is the bedrock of combinatorics. Master it. In exams, when you see a problem asking for the total number of ways to combine independent choices, think of this principle first. It's often the starting point for more complex questions. You're on a road trip with friends. Now, you've narrowed down your favorite songs to a list of 10, but you only have time to play 4 before you arrive. The order of the songs creates the vibe, so it matters. How many different 4-song ordered playlists can you create from your 10 favorites? Since the order is crucial, this is a permutation problem. Let's visualize it. For the first song, you have 10 choices. Once that's picked, you have 9 songs left for the second spot, then 8 for the third, and finally 7 for the fourth. Using the counting principle, that's 10 times 9 times 8 times 7. This calculation is formally known as a permutation, written as 10p4. The formula is npr equal to n factorial over n minus r factorial. Plugging in our numbers, we get 10 factorial divided by 10 minus 4 factorial, which is 10 factorial over 6 factorial. When we expand this, the 6 factorial in the numerator and denominator cancels out, leaving us with exactly what we started with, 10 times 9 times 8 times 7. This gives us a massive 5,040 possible playlists. Here is your IB exam tip again. Now, look for keywords like arrange, order, line up, or sequence. These are strong indicators that you need to use permutation formula, which is available in your formula booklet. A teacher needs to form a 3-person committee to organize a school event, and there are 15 student volunteers. The challenge is how many different groups or committees can be formed. This time, the order in which students are picked doesn't matter. A committee of Alex, Ben, and Chloe is exactly the same as a committee of Chloe, Ben, and Alex. This makes it a combination problem. Now, let's first think about the permutation. The number of ways to pick and arrange 3 students from 15 is 15p3, which is 2,730 students. But this number overcounts. For any single group of 3 students, we've counted all the different ways to arrange them. How many ways can you arrange 3 students? That's 3 factorial, which is 6. To get the true number of committees, we must divide the permutation result by 6 to remove these duplicates. 2,730 divided by 6 gives us 455. The formal way to do this is with the combination formula NCR, which is n factorial over r factorial times n minus r factorial. For our problem, that's 15c3. This gives us 15 factorial over 3 factorial times 12 factorial. After cancelling out the 12 factorials, we are left with 15 times 14 times 13, all divided by 6, which is equal to 455. So there are 455 unique committees possible. Another IB tip: the biggest challenge is distinguishing combinations from permutations. Look for keywords like choose, select, group, or committee. All of these keywords imply that the order doesn't matter, so we use combinations. Misinterpreting this is a very common mistake, so always ask yourself, does the order matter? Yes or no? Thank you for watching and see you next time.